Now that you have factored trinomials, we're going to work on factoring by grouping, and this is probably most everyone's favorite way to factor if possible. Okay, so this is going to be a little different than the factoring with trinomials. For one thing, whenever we factor by grouping problems, oh, I don't know if you can see that. Let's see. We'll try this again. Grouping problems must have at least 4 terms. So that means you can't do a grouping problem on a trinomial. So grouping problems have to have at least 4 terms. Okay, grouping is a different way of factoring, and what's going to end up happening is we're basically going to be just doing GCF. So this is just GCF, and it's actually GCF 3 times. Alright, so let's start off with our first example. So number 1, let's do 12a cubed minus 9a squared plus 4a minus 3. Excuse me. So what we're going to do is we notice that there are 4 terms in this polynomial. So what we're going to do is, it's called grouping. We are going to group them 2 and 2. Alright, now for what you guys are doing today, most of them can be grouped in the order that they're written. And once you see how this works, you'll start to understand why a certain grouping matchup wouldn't work. Alright, so what we're going to do is we are, just for a few minutes, going to ignore this side right over here, and we're going to do the GCF of these two. So when I look at these 2 problems, so remember we're ignoring this one over here. When I look at these 2 problems, I see a GCF of 3a squared. And if I take a GCF of 3a squared out of these 2, that's going to leave me with 4a minus 3. Alright, now remember, the way to check is to distribute. So I took out a GCF of 3a squared, and it left 4a minus 3. Alright, now I'm going to cover this up for just a minute, and I'm going to look at these 2 and take out a GCF. So when I look at these 2, I only see a GCF of positive 1, and if I do that, that would just leave me with 4a minus 3. Okay, now if I look at these 2 groups, I factored the GCF out of this group, I factored GCF out of this group, and I ended up with identical parentheses. And that's not a coincidence, that's on purpose. So you need to have the same thing in your 2 sets of parentheses. Well, now this works just like yet another GCF, because they both have a 4a minus 3. And if I take the 4a minus 3 away from this first group, that would leave me with 3a squared. And if I take the 4a minus 3 away from this group, that would leave me with a plus 1. Now, remember, the way to check is to FOIL. So if I multiply those 2 together, I get 12a cubed. If I multiply the outsides together, I get 4a. If we multiply the insides together, that would be 9a squared. And if we multiply the last ones together, we would get negative 3. So this is, in the end, your answer. Alright, so just to recap what we did, we separated them into groups of 2, took the GCF of this group, then we did the GCF of this group, we ended up with the same set of parentheses, which became the GCF of our last group. And then the leftovers go back over here. All right, let's try another one. This time, let me mix up some. So, for example 2, let's say we had 2p to the third plus 5p squared plus 6p plus 15. Now again, most of these are going to be able to be grouped as they're written. And now that we know, if we don't get the same parentheses, then we group them the wrong way. Okay, so that was not on accident, that was on purpose. All right, so first thing I'm going to do is ignore this group over here, and I'm going to do GCF. And out of these two, they have a p squared in common. So if I take out the p squared, that's going to leave me with 2p plus 5. And that is just working on this first group right here. All right, now I'm going to work on this group. And out of here, I can take a GCF of a positive 3. And if I do that, I will get 2p plus 5 left over again. So now when I look at my two groups, they both have the same numbers in the parentheses, and that's not on purpose. I mean, sorry, that is on purpose. It's not an accident. Sorry about that. So one of my parentheses is 2p plus 5 because they both had that. And now if I look at what's left over from the first group, a p squared is left over, and from the second group, a plus 3 is left over. All right, now the way we check this is to FOIL. So if we FOIL this back together, this first gives me 2p cubed. The outside gives me 6p. The inside would be 5p squared. And the last ones would be 15. So that is your factored form of that polynomial. All right, let's try one that involves more than just one variable. So, all right, give me a second to, all right, let's do, okay. So here's number 3. Number 3. Okay. How about let's do 8xy plus 6x minus 20y minus 15. Alright, so we have two variables in this one. Alright, so I'm going to, again, group them just as they're written. It could be, there's possibly more than one way to group them. Like I could decide to group those two together because I see a GCF of 4 and y. And I could group those two together because I see a GCF of 3. So you don't always have to group them as they're written. You could group them in different, you know, like the first and the third could be in one set and those two could be in another set. All right, so first out of this set, the first grouping, I see a GCF of 2 and x. And if I take that out, that is going to leave 4y plus 3. And again, you can always check by doing distributive property. All right, now these two, if I look at this group, I see a GCF of -5. And that would leave, if I factored out a negative 5, that would leave 4y plus 3, which is what I needed to get. So now I know that one of my answers is 4y plus 3, and the other one is what's left over, which is 2x from here and a minus 5 from there. And again, you can always check these by foiling your answer back together and making sure that you get what you started with. Alright, that should cover it. If you need to go back and rewatch the video, please do. And you should be able to go get the factoring by grouping worksheet.